So as denoted here in the problem, this is about pair differences. They're not two independent samples because we've got older brother, younger brother, and these are paired up. So we're trying to say, is there a difference? So the claim is, tests claim that the older brothers have a higher IQ than the younger siblings. So they did that subtraction. They said older minus the younger, got these differences. The mean difference is 2.5. The standard deviation is 3.5. And that's just for the differences. And that's all we care about because of the match pair situation. So then you got to remember when you're doing a match paired test or analysis, you have the mean difference is equal to 0, meaning there's no difference between the two brothers' IQs. And then because for H1, because they said that the older brother has a higher IQ than the younger brother on average, we're going to say that it's actually because of the way we subtracted it here, or the way the table did it for us. They said older minus the younger. They think it's higher, so we're going to say greater than 0. So it's a right-tailed test. And let's see, what do we got? Well, we've got our X bar, we got our S, we've got N is 10, all stuff we need for the calculator. So I went ahead and filled in the information and out of that IlSilco site. I choose one sample because we're just talking about the differences. I notice I use my mu sub d 0 as the population mean. That's the hypothesized center saying that there's no difference between the two. And here's the sample difference. Here's the standard deviation 10. I left it as 0.05. They have us do a couple of different things in this problem. I said a right-tailed test. Give me that for a t-score. Give me that for a p-value. So 0.05 to 0.0251. So that's greater than the 1% level of significance. It's less than the 5% level of significance. So here we can't reject HO, meaning the data doesn't support the older brothers have a higher IQ than the younger brothers. And this one we can reject HO at the 5% level because 0.025 is less than 0.05, where it's not less than 0.01. Okay, so that's maybe if you're having a little trouble with that, you need to hear that. So reject HO, yes, it looks like on average older brothers have a higher IQ than younger brothers based on this data. Alright, so I hope that helps you use this applet for this.